By now, you should have already learned a little bit about how the periodic table was constructed, how early scientists did that. And today we're going to look at the modern periodic table and see some of the different groups of elements that are there. Just a quick reminder, here's what the periodic table looks like. And usually on a periodic table, there's almost always a key that tells you what everything represents, okay? So the atomic number is somewhere on top. It could be top left, top middle, top right. There's always a 1 or 2 letter symbol. There's a name, and then the atomic mass is always at the bottom, okay? The thing you need to know is in the periodic table, there are groups and periods. Periods, like the periodic table. So the groups are the up and down columns. So here's a red group and here's an orange group. Since this is the second one over, this would be group 2, the red would be group 1, okay? So the groups are these up and down columns, okay? And one important thing you should know is that elements in a group all have the similar properties, okay? They all behave similarly, they act alike, sometimes they look alike, and they're going to do some similar things with their electrons too, but more on that later. And then there are also periods on the periodic table. Weird, right? And so the periods are the rows. So these two would be period 1. These two reds are in period 1. These oranges would be period 2. Yellow is period 3. Green is period 4. Light blue, 5. Dark blue, 6. And then the purple is 7. Okay? So groups are up and down columns, and periods are rows. All right, so we are going to learn the name of some of the groups on the periodic table, not all of them. And so each one of these groups that's listed off here to the right, we're going to go through individually and talk about one by one. We're going to start right off with group number 1, the alkali metals. One thing to notice here is my arrow is pointing down to lithium and I've covered up hydrogen. Why is that? Well, hydrogen is technically a non-metal, and so it's not really part of the alkali metals. You might want to know, well, then why is it in group 1 in the first place? And that's because hydrogen ends up behaving like the things that are in group 1. So it got placed there even though it's not an actual metal. The alkali metals, here's a picture of them over to the right. They are all shiny, they're all soft, and they react. They're super reactive with the air or with water, okay? Next up are going to be the alkaline earth metals. That's group 2, okay? Group 2 right here. It includes all of them, no special circumstances here. We've got a picture off to the right with what they look like. Some of you might be surprised that that's what calcium looks like. Yeah, that stuff that makes up your bones. It's a shiny metal. Isn't that weird? And so similarly, these are shiny. They're silvery white. They're somewhat reactive. Why are they called earth metals? It's just an old science term that means it doesn't dissolve in water. Okay, so we're really not going to worry about that, but that's kind of where it came from. Here we go. In the middle, I put a gray box around it. Those are the transition metals. Okay, so groups 1 and 2 were metals. This group in the middle, it's not group 3, it's called the transition metals. And basically they have lots of different properties. They look very, very different. So there's not one like summary thing we can say about them, but that's where they are right there in the middle. Some of you might be wondering what the heck is going on with these two squares. Well, let's talk about that. Those two, if you notice, we have a jump on the periodic table. Here's number 56. And then 57 to 71 are in this green box, and then it goes all the way to 72. Well, what the heck is up with that? Well, here's what's going on. What scientists did is they took that whole row of 57 to 71 and they put it down here. And then we pick back up with 72. Weird. Same thing happens in the row below it. We got 88 radium, and then 89 to 103 should be here. And then we've got 104 right there. So notice, follow our arrow down. Here's 89 to 103. You can see this is why they're sometimes called the inner transition metals, because they are technically part of the transition metals, but they've been plucked out. Honestly, most chemists don't use them. They're man-made. They're around for maybe just a fraction of a second. And so they're kind of pulled out down below. And also, quite frankly, it makes a periodic table really hard to print on one sheet of paper when it goes that far across horizontally. So pulling them down kind of helps keep it nice and compact. This row, the 57 row, is called the lanthanides because number 57 is lanthanum. And this other row down here right below it, is the actinides because number 89 is actinum. Okay. All right, moving right along, you'll notice we did group 1, we did group 2, we did our transition metals in the here, we talked about why these green ones are down below, and we are skipping all of these. Some of these groups, that's like the carbon family and the nitrogen family, we're not really going to worry about those family names and things like that. We're going to go straight to group 7, the halogens, okay? You might be wondering how I got to the number 7 all of a sudden. If this is group 1 and this is group 2, that makes sense. Well, sometimes with the numbering, what we do is we do 1, 2, skip the transitions, and then 3, 4, 5, 6, 7. Okay. So that's where that comes from. The halogens are group 7. Halogen means salt producing. And so a salt is basically any metal and non-metal that's bonded together. And these guys love to bond with metals. And so they're going to produce some kind of salt. And yes, the salt that you shake on your French fries is one of them, but that's just one of many different kinds of salts. So don't be confused. And as you see over here, we've got, they look very, very different from each other. And this group is really interesting because they're the only group that has solid, liquid, and gas in it, which is kind of cool. You might not be able to tell from this, but bromine is actually liquid at room temperature. And last but not least, we're going group number 8, the noble gases. Noble gases are called that because they are very low reactive. They don't mix with anyone, just like back in the day when there were peasants and, kings. The kings were called the nobility, and the nobility did not mix with the common people. The noble gases don't mix with the rest of the periodic table. Noble gases are usually colorless and odorless. But you might be like, what? Because like neon, and look at this picture, where are those colors coming from, huh, Miss Culberson? Well, that's because when you run electricity through them, they turn colors. But just normally, they're not colored at all. So that's your overview of the groups and the parts of the periodic table that you should know and be familiar with.